Right, Serena? Let's start off with number one. How would I do this?
First, you try to get rid of the denominator on the left-hand side. X is
Right?
actually to multiply by x plus 3 squared on both sides.
Okay. On the left-hand side, it's going to be x minus 2 all over x plus 3. And I'm going to put them in brackets, right? I'm going to multiply
Mhm.
by x plus 3 squared. All right, talk to me. What's the next line going to look like?
Well, one of the x plus 3's will cancel out with the x plus 3 being squared. So, and anything by 0 is just 0. So the next line would be in brackets x minus 2, in other brackets, x plus 3 is more than or equal to 0.
Ah, right. What about the next line?
Now you put each bracket equal to 0, so x minus 2 equals 0.
Wait there. A step I like to put before I do that. I like to put I like to put the entire thing equal to 0 to show that we find any roots. So I'll put this equal to 0, right? Okay. And in the next line, yeah, you would say x minus 2 is equal to 0. And then you would say x plus 3 is equal to 0. What
0.
next?
X would be equal to 2,
Right? X would be equal to 2.
and then x would be equal to minus 3.
Yeah. Right. Nabil, I lose you anywhere over here at all? At all, at all, at all? Talk to me.
No, I understand up to there.
Right, wood. Avinash, I didn't lose you anywhere, right?
Funny enough, that is actually how far I got.
Okay. The next thing you're supposed to do was sketch the graph, right? And figure out where to shade. But there was a trick with this question that most students would have lost a mark for. So, Serena, let's continue. So, Serena, we just found your roots, right? Yeah or no?
Yes, sir.
So we found your roots. Great. Additionally, right? If you were to say expand out this, you'd end up with a quadratic that is a maximum or minimum.
A minimum.
Right. A minimum because you'd end up with x squared, yeah?
Yes, sir.
Right. Nabil. Nabil, let me know if you understand that.
Yes, sir.
Okay, wood. So now I'm gonna draw my graph. Right? Avinash, did you understand why I said that my quadratic curve would have been a minimum?
Yes,
Okay, and again, if you were to expand this out, Avinash, and x by x is x squared, positive x squared. Yeah.
yes,
So that makes sense, right? Over here now, x is gonna be minus 3, so I'll put it over there, and x is 2, so I'll put it over here. And we just recognize that it was a minimum. Okay. Yeah, guys, I wonder if you understand that. Yes or no?
Yes, sir.
All
yes,
right. It looks Zachary, how everything going?
So everything going good.
You're mashing them up in pan.
Mhm.
Zachary the pan man, the pan legend. Right. Yeah, Zachary, did the finals, would the finals, did it already happen or not?
Yes, sir, the finals already happened.
I saw on the chat that you played second or something.
Yeah, we placed second.
Big up yourself, big up yourself. Right? And that was amongst all of the schools in Trinidad.
Yeah, most of them.
Well, big up yourself. What did they give all for that though? Like placing second. I'm
Uh,
curious.
trophy.
A trophy. Ah, well, the honor, right? The honor. The honor
Yeah.
is there. But I thought you'd like get something else, to commemorate that
Nah,
big W.
nah, sir.
It's boy. All right. So let me continue, right, Serena? So, Serena, if you look at this, we want to figure out where the quadratic is going to give us what? Say that again. Okay, I barely hearing you. I was hearing you like just now, but I'm not hearing you anymore. I hearing you like if you're under the ocean and it's very quiet.
More than or equal to 0.
Right. If it's more than or equal to zero, is it positive or negative?
Positive.
Positive. So let me ask that question. If I take a value that is less than -3 and I take a read off, is it going to give me a positive value or a negative value?
Positive value.
Right. So does it make sense for me to shade over here?
Yes, sir.
Yeah, so I could shade over there one time. Okay, great. If I go on the inside, right? So Serena, see I shade something that is more than -3 and I take a read off. That's going to give me a positive value or a negative value.
Negative value.
Do I want a negative value?
No, sir.
No, I don't want a negative value. If I take a value that is less than 2, am I getting a positive or a negative?
A negative.
So that is incorrect as well. What if I take a value that is more than 2?
You get a positive value.
Right. You understand the concept?
Yes, sir.
Good. So for this question, you gotta be careful how you're writing your solution, eh? Be careful. Let me show you what I mean by be careful. Watch this. If I were to ask you all, at what value for x makes the function undefined, what would you tell me? What value of x makes the function undefined? What would you tell me? In the previous classes, I said that we can't divide by what? What did I say we can't divide by?
0.
Mm-hmm. Is there any number that would make the denominator 0? Say that again.
Could you repeat?
0.
Could you repeat what you asked?
Right. So what value of x would make the denominator 0 over here? What is the denominator in this question?
So it will be my -3.
Yes. Are you guys seeing that as well? When x is -3. Nabil, when x is -3, what happens to the denominator?
Becomes 0.
Yeah. And can you divide by 0? Tell me, Nabil, can we divide by 0?
Now, so
Nah. So, Nabil, you think I could put in a solution? You think I could say x is also equal to -3?
no,
Yeah.
No, I can't put it in a solution. Zachary, I can't put it in a solution. Guys, can't do that. Because when x is equal to -3, my denominator is going to be 0, and you can't divide something by 0. It breaks the function. So look at how I'm going to write my solution. I'm going to say x is such that x is... Now, if you look at these signs, right? If you look at the sign, you might be tempted to say less than or equal to and more than or equal to, but there's a catch here. So, Serena, I'm sure maybe you would have write this. Maybe you would have say x is less than or equal to -3, union x is more than or equal to 2. Did you write that?
Yes, sir.
Okay, but you would lose a mark, eh? You would lose a mark.
Mm-hmm.
This is saying that x could be less than or what? Less than or?
Or equal to.
Right, but if x is -3, what's gonna happen to the function?
Is gonna turn to 0.
No,
It's
it's
gonna
gonna
be undefined.
it'll be undefined. It'll be undefined, right? Because the denominator would be 0. So, do you think I could include equal to -3 in my solution?
Yes, sir.
No, I can't do that. Here what I'm saying, eh, guys, you cannot do that. You cannot do that. So if you guys wrote x is less than or equal to -3, that would be wrong. Wrong. This is the correct answer. You would write x is what? Tell me, Serena. If it can't be equal, what does that leave me with? X is what?
Less than -3.
Right? Could I leave the more than or equal to 2? When x is 2, does it break the function, guys? Does it break the function?
Yes, sir.
Talk to me, guys, the rest of you all. When x is 2, does it give you 0 in the denominator?
No, sir.
Nah. So technically, you could use that as well. Now, Serena, there's a really interesting way you could look at this, right? Serena, check this. Look at the numerator. The numerator is x minus 2. You see now, right, Serena? The numerator is x minus 2.
Yes, sir.
When x is equal to 2, you'd get 2 minus 2. 2 minus 2 is what?
0,
0 over anything is?
0.
Yeah. And so when x is equal to 2, you actually get 0. So if you didn't want to do all of this, another method that I saw the other day that was really cool is you could take a value that is less than 2 and plug it in and see if it's giving you more than or equal to 0. Or you could take a value that is more than 2 and plug it in and see if it's giving you more than 0. You understand what I'm saying, right, Serena? Or not?
Yes, sir, I understand.
Because, guys, Avinash, Shina, Nabil, Takri, we want to figure out where x would give us something more than or equal to 0. So when you look at this function, right, remind me, guys, if I had, say, something over 5, what would I have to put here to give me 0? Tell me, guys. Or what I have to put on top to give me 0? Zachary, tell me. If I have something over 5, or what I need to put on top to give me 0?
0.
I would have to put 0. So, Zachary, what value of x would make the numerator 0?
Positive 2.
Positive 2. So when x is equal to 2, doesn't that give me 0? Because 2 minus 2 is 0, and 0 over anything is 0. You understand what I'm saying?
Yes, sir.
So another way you could do this question is you could write it down, right? So you could say x is equal to 2. And Zachary, what you could do is you could actually pick a value that is less than 2, right? And you could plug it in here. So maybe you might plug in 1, and you're going to plug it in, and you want to see if it's going to give you something more than or equal to 0. If it does, then the solution would be x is less than or equal to 2, or x is more than or equal to 2. And Zachary, that's one thing you could do, right? And then the other thing you could do is you could look at what makes the denominator 0. So Zachary, remind me, what makes the denominator 0?
-3, sir.
-3, right? Here what you could do, right? You know that the function breaks when x is -3 because it can't divide by 0. So what you could do, Zachary, is you could actually plug in values less than -3 or more than -3, and you're going to plug it into this, and you're going to see if it gives you something more than or equal to 0. If it does, then that will be part of your solution. That's another way to do it without drawing the graph. And I could actually show you how to do that. It's a really cool way to do it. Right? So guys, did you all get through the first question? Let me know, guys. Did everybody get through with the first question? Yes or no? I don't like the silence. Serena, you get through?
Yes, sir.
But I
All
did
right,
it
Shane.
wrong.
But Shayna, did you note this? Or did you leave
No,
it?
sir.
Yeah or no?
No.
No, you'll lose a mark. If this question
Yeah.
was 6 marks, you'll lose a mark. If it was 4 marks, you'll lose a mark. Yeah. Right? Nabil, you don't think about that? You don't make the connection that x can be equal to -3 because it can't divide by 0.
Yes, sir.
Okay, good. All right, let's move on. Before I move on, though, I just want to show you the alternative method, right? In case you don't want to plot the graph and whatnot, this is an alternative way you could do it. That's also really, really simple. Although this is a standard approach, you should do it. Let's just say push comes to shove and you forget how to do it like that. This is an alternative way to do it. That's extremely easy. Right, so Zachary, let's examine the alternative way to do it, right? So Zachary, what value of x makes the numerator 0?
+2.
Right? So you're gonna say x is equal to 2. Well, you should probably write x minus 2 is equal to 0, and then you're gonna write x plus 3 is equal to 0. Because you're trying to figure out what values for x makes the numerator 0, and what values for x or value makes the denominator 0. So, Zachary, when x is equal to 2, the numerator becomes 0, right? And when x is equal to -3, the denominator becomes 0. I mean, if you fully understand that.
Yes, sir.
Great. So we want to figure out where, if you plug in x, you're going to get what?
0.
Look at the inequality sign.
Less than or equal to 0.
No, that is not less than.
A
Look,
greater.
a way to think of this is an arrow, right? Imagine you're a number line.
Yes, it's greater than or equal to 0.
Right, because if you're pointing in this direction, the value is getting bigger and bigger and bigger. So it's more than, right? Anytime you forget to just look at the arrowhead. Great. So Zachary, we want to figure out values for x that when you plug it in, gonna give you what?
Something greater than or equal to 0.
Exactly, right? Exactly. So when x is equal to 2, it gives us 0, yeah?
Yes, sir.
Right. So here's what we're gonna do. Right. So Zachary, we want to test first values less than 2 or values more than 2.
Values less than 2, sir.
All right, no problem. So x is less than. All right. So pick a value that's less than 2.
1.
Right. And then I'm going to plug it into this, right? So I will write 1 minus 2 all over.
1 plus 3.
Where's 1 minus 2?
1. Well,
Nah, 1.
minus 1. Minus 1, sir.
Minus 1, right? And where's 1 plus 3?
4.
4. Is negative a quarter more than or equal to 0?
Nah, sir.
Nah, that's actually less than 0, yeah?
Yes, sir.
Right, so is that what we want?
Nah.
Nah, that's not what we want, right? This is not what we want. So do you think, okay, so if x is less than 2 is automatically wrong, what do you think our solution is going to be then?
X is more than 2.
Exactly, because if x is less than 2, give us a value that is less than 0. Then x is more than 2 should give us a value that is,
Greater than 0.
right, give me a value that is more than 2,
3.
right? So if you plug that in, that would be 3 minus 2 all over 3 plus 3, right? What is 3 minus 2?
1.
And 3 plus 3 is 6.
Yep.
It is 1 over 6 more than 0 or less than 0?
More than 0.
Right. So is that what we want?
Yes, sir.
Right. So automatically, this is part of a solution, right? I mean, if you understand that.
Yes, sir.
Right? And we want to figure out where it is also equal to 0. So if we want to figure out where it is also equal to 0, then I would have to say x is more than or equal to 2 right? Because when x is equal to 2, isn't it 0? Because 2 minus 2 is 0.
Yes, sir.
Right. So I found my first solution. X is more than or equal to 2. It's the same concept for x is equal to negative 3. Just going to test, right? Right. Right. So talk to me. Zachary, give me a value that is, um, we want to start off with more than negative 3 or less than negative 3.
Let's start negative 3.
Sure. Right. So we're going to say x is less than negative 3. Why can't I say x is less than or equal to negative 3? What happens when x is equal to negative 3?
The functional breaks it.
Right, the function will be undefined. That's the proper thing to say. The function,
Yes,
right? The function will become undefined. Right. So tell me what's a plugin. So give my value less than negative 3.
-4.
Right. If we say in that, that's going to be -4, -2 over what?
-4 plus 3.
What is -4, -2?
-6.
What is -4 plus 3?
-1.
What's a negative divided by a negative?
Now positive.
Right. So talk to me. Is that part of my solution then? Talk to me. Is that part of the solution? What is 6? 6 is what?
6 is less than -3.
Nah, look at what we
But
wanted. We wanted to figure out where it is going. We want to figure out values for x that when you plug it in, it's going to give you more than or equal to 0. So when we plug in x is equal to -4, do we get something more than 0?
yes,
Yeah, 6 is more than 0. So therefore, this is correct. And therefore, Zachary, if I take any value that is less than -3 and I plug it in, will I get a positive or a negative?
positive.
Exactly. I'm going to get a positive, right? So that's another way you could do it, and you don't have to do no graph or anything, and it's like really, really simple, I would say, compared to the other method. I don't think you're gonna learn that in school, but that's really, really simple.
So,
And
but, so for questions like these, they'll ask you to draw the graph.
they wouldn't outright ask you to draw the graph, right? They wouldn't ask you outright to do it, but I recommend doing it because if you're doing this method, you need to see how the graph does look like. So you need to draw the graph to see it. And I mean, it wouldn't take you long to find your roots and draw your graph and then figure out where to shade. You do not sketch. You don't do anything fancy, you just do not sketch. So Zachary is just putting on your roots and you're putting down the shape of the graph. That's it.
Yes,
So here, Zachary, according to this testing over here, we were able to figure out that x would be such that x is what?
so you can repeat.
According to the testing we did here, we did this testing and we did this testing. What did we come up with?
X is greater than 0.
And we came up with x is more than or equal to 2. That was correct. Because when x is more than or equal to 2, you get
Or
a value that is more than 0, which is what we wanted, right? And that was also correct.
X is less than -3.
Yeah. Right, and you typically write the smaller one first and the bigger one after. Isn't that the same answer we got previously?
Yes,
Yep. Um, Serena, did you ever think about it like this? Or nah?
No, sir, I didn't.
Yeah, well, it's another cool way to figure it out. It's a cool way to figure it out, right? So you guys can take a screenshot of this. All right, take a screenshot. Let me know when you have a screenshot.
Yes, sir.
All right. What were the rest of you guys?
Yes, sir.
Yes, sir.
Okay. So, Nabil, I believe I told you to help me with question two.
Yes, sir.
Mm-hmm. All right, well, let me go, right? You think you're ready for this?
No.
No way. All right. Well, here what, right? You go figure it out. It'll be fine. It'll be fine. Now, Nabil, with all the questions you see so far, it was more than or equal to or less than or equal to what? To what?
0.
Yeah, but this time it's more than or equal to one, so you're probably wondering what to do.
Yeah.
Probably feeling like like what boy? What is a good sticker to describe how you're feeling? Which one? How you feeling right now? Feeling like this? When you see this?
Yeah, yeah.
All right. So, Nabil, if the questions we're accustomed doing have more than or equal to or less than or equal to zero, what would I need to do to make this side zero? Talk to me. What I need to do to make this side zero?
I put -1.
Yeah, we'd have to minus one from both sides.
Yeah.
Another way to think about it is take the one here and just move it across. Because
Yeah.
Nabil, if you take everything from this side, right, and you move it across, right,
It become
um,
minus.
it become minus one, and if I take everything and move it across, um, it's just gonna be zero on the right hand side now. So that's what I'm going to do. So I'm going to write 3x minus 2, right? All over x plus 3, right? And I'm going to move across that 1. So that's going to be minus 1. And it's more than or equal to what? Tell me, Nabil.
0.
0, yeah. Now here what? There are multiple ways you could work this out, right? But I'm going to show you the simplest one, I believe. Nabil, do you know how to find LCM?
Kinda.
Kinda? Nah, you know how to find LCM. Watch. If you have something like a half plus or two, right? What the LCM on that would be?
6.
Yeah, because 2 could go into 6 and 3 could go into 6 as well. Do you understand that?
Yeah.
Right. So nothing hard about that. You know what to do. LCM is just the lowest common multiple for which both numbers go into. Okay. All right. So over here you have 3x minus 2 over x plus 3 minus 1. Would I confuse you if I wrote 1 as 1 over 1? Or are you still okay with that?
Okay with that.
All right. So we should probably find the LCM here now. What do you think the LCM between x plus 3 and 1 would be?
3.
Nah, if you put 3 over here, right? Could x plus 3 go into 3? The answer is no. Let me give you an example, right? If we had something like 5 plus 3, could 5 plus 3 go into 3?
No.
No, because 5 plus 3 is actually more than 3. How would it go into 3, right?
Yeah.
So, but let me ask that question. Could 5 plus 3 go into 5 plus 3?
Yeah.
How much times?
1 time.
Right. So, we think x plus 3 would be able to go into?
X plus 3.
Exactly. So x plus 3 is the answer, and you're probably wondering, well, why? How could 1 go into that? I wonder why. Nabil, let me look at this from a logical standpoint, right? Let me just say that x was, say, 5. So 5 plus 3. And we just now say 5 plus 3 could go into 5 plus 3?
Yeah.
Okay. Could 1 go into 5 plus 3?
Yeah.
Yeah, because in 5 plus 3 is 8. It's looking weird, right? But it's 8. How
Yeah.
much times 1 could go into 8?
8 time.
Right. So how much times do you think 1 could go into x plus 3?
Um,
I promise it's the exact same concept, eh? So 1 could go into 5 plus 3 how much times?
8 time.
Which is 5 plus 3, yeah?
Yeah.
So 1 go into 5 plus 3, 5 plus 3 times. So 1 could go into x plus 3 how much times?
X plus 3 times?
Yeah, right? Because here what, Nabil, I know it's looking a little complicated because it's letters you're seeing. You're not seeing numbers. But x could be any number. X could be any number, right? So x could be any number. Yeah, x could be any number, right? And so Nabil, if x was any number and 1 could go into any number, that amount of times?
Yeah.
Like think about if x was say 7, 7 plus 3 is 10. How much times 1 could go into 7 plus 3, which is 10?
7 plus 3?
Exactly, 10 times, which is 7 plus 3. See, you're sure you're not confused about that, right?
No.
All right, so Nabil, long story short, x plus 3 could go into x plus 3 how much times?
1 time.
Right, it could go into it. And how much times could 1 go into x plus 3?
X plus 3 times?
Exactly. I know it's something a bit weird, right? Because you're
Yeah.
saying letters and thing, but it's the same concept, right? It's the same concept you would apply if it was if it was numbers. So there we go. X plus 3 into x plus 3 is 1, then you'd multiply this by 1. 1 by anything is what? If I ask you, what is 9 by 1? What are you going to tell me?
1.
Nah, 9 by 1 is 9.
Oh, 9, 9. Yeah, sorry.
That's okay. So if I multiply 1 by 3x minus 2, it just give me back what?
3x minus 2.
Right. So that'll be 3x minus 2. And over here now, 1 could go into x plus 3 how much times?
X plus 3 times.
Exactly. So I can't forget the minus sign. I write back the minus sign. Mm-hmm. And in brackets, I'm going to put x plus 3. Why? Because 1 could go into x plus 3 times, right? So 1 by x plus 3 is just what? Where's 1 by x plus 3?
X plus 3.
Right. And we can't forget the minus sign. Okay, let's continue. All right, so now we have to expand the bracket. So what is negative by x?
Negative x.
And what is negative by positive 3?
Mm, negative 3.
Right. Right, what next? See if we can simplify the numerator.
It will be 2x minus 5.
Yep, because 3x, if you have 3x's and you take away x, it'll be 2x,
Yeah.
right? And then minus 2 minus 3, right? You take $2, you take $3 more. Again, think of it like taking money, right? If you take $2 and then you take $3 again, altogether I would have taken $5. So minus 2 minus 3 is minus 5 all over x plus 3. Okay, so you understand that, right?
Yeah.
Does it look like something you're accustomed with now?
Yeah.
Talk to me. What's your next steps?
Um, you multiply it by the denominator and square it.
Right, so by the denominator squared, right? And if we want to save time, we could jump to the correct answer one time, right? Because in the exam, you don't have to write the full working for every single line. So Nabil, if I multiply by x plus 3 squared, we already know what's going to happen. X plus 3 squared means x plus 3 by x plus 3. So one of the x plus 3's will cancel off. So what will I be left with on the left-hand side?
2x minus 5
2x minus 5
by x plus 3.
Right, and if you're confused, remember, we're multiplying by x plus 3 squared, which is x plus 3 by x plus 3. We have an x plus 3 in the denominator, so that's going to cancel off with 1 on the top. And that's going to leave us with 2x minus 5 by x plus 3. Understand?
Yeah.
And on the other side, right, we're multiplying x plus 3 squared by 0. Anything by 0 is?
0.
Great. So what to do next?
You make it equal to 0.
Right, so you're going to say 2x minus 5 is equal to 0. and you solve for x. Right, what would x be?
2x minus plus 5 is equal to plus 5.
Yes. When you're trying to find for an unknown, you want to isolate it. So you're taking all the numbers and move it across, and then you divide by the coefficient of the number. So I'll move across the -5, that's into +5, and what am I going to do next?
Divide both sides by 2.
Yep. So in other words, when x is equal to 5 over 2, it makes this what? Talk to me, Nabil. When x is equal to 5 over 2, if you plug it in into this, what you get?
Um,
Alright, so let's reverse engineer this, right? Nabil, you had put 2x minus 5 equal to what?
0,
Right, so you solved for the value of x that would give you
0,
right. So when I plug x is equal to 5 over 2 into this, what will I make that bracket?
0.
Yep, 0. Right, because remember, 0 by anything is 0. Forget this one line. Give me a second. Right, so normally when you're doing this, the line after, you would write it back and you would put it equal to 0 because you're finding for the roots. Do you remember what the roots are?
Um,
All right.
no.
All right, so the roots are where the curve is cutting the x-axis.
Yeah, I remember now.
Right. And we also call it the x-intercept.
Yeah,
Right? So in other words, we are trying to figure out, and by the way, at the x-intercept, what is the y value? What is the y value at the x-intercept? Do you know?
0.
Yeah, 0. So that's why we're putting it equal to 0, because we're trying to figure out the values of x that give us a y value of 0. Because at the x-intercept, right, when it cuts the x-axis, the y value is 0. So when x is 5 over 2, it makes this bracket 0, and 0 by anything is 0. Right, on to the next one now. How will I figure out for the other value of x?
It will be x is equal to minus 3.
Yeah, x plus 3 is equal to 0, and x is equal to -3. Because when x is -3, doesn't it make the bracket 0?
Yeah,
Great. Now, question, if you were to expand this, would the coefficient of x squared be positive or negative?
positive.
Right, what would the coefficient be for x squared?
2x squared.
Yep, it'll be 2, right? Be 2x squared. So if the coefficient is positive, we're looking at a maximum graph here or a minimum graph here?
Or minimum.
A minimum, right? Don't worry, I'll show you an easier way to do this question. Slightly easier, nothing too different. You could always approach it using the analytical method, but this is like the standard approach they typically want to see. Right? So yeah, let me continue, right, Nabil? So my roots are 5 over 2, which is 2.5, and -3. Yeah? So 5 over 2, where would that be? To the left or to the right? 5
Right?
over to the right, yeah. So 5 over 2, that's gonna be over here. And -3 is gonna be over here. We just now figured out that this is going to be our minimum graph. So that's gonna look like this. Avinash, why is this our minimum graph? Talk to me.
So because the number is a positive,
And where's the number?
the no roots
Talk to me. Remind me, what was the coefficient for x squared here?
um 2
2, yeah, yeah.
because yeah.
Right. Because when you expand this out, you're gonna get 2x squared. Right. Sheena, did you do it like this? or did you multiply by x plus 3 squared throughout? And then you expand it out and you simplify and then you factorize.
So I didn't tell you how to.
You do it like how I did it?
Yes, sir.
Okay. Right? So Nabil, we want to figure out where we're getting what.
More than or equal to 0.
Right. Let's see what happens if I go less than minus 3. So again, I'm going to draw a vertical line. It cuts the graph over here. I'm going to take a horizontal read off. Does it give me a positive value for y or a negative value for y?
Positive.
So is that part of my solution set?
Yes.
Yes, because we want to figure out where we're getting values that are
More than or equal to 0.
right. Great. You sure you understand it?
Yes, sir.
I bet. Zachary, I needed to tell me, be honest with me. You understand this?
Yes, sir.
All right. Zachary, let's examine the other parts of the graph, right? So Zachary, if I take a value that is in between minus 3 and 5 over 2, we just say I take a value over here. You see it cutting the graph over here, right?
Yes, sir.
All right. If we take a horizontal read off, that's going to give us a positive value for y or a negative value for y.
A negative value
But we want to figure out where y is.
greater than or equal to 0.
Right. So do you think I could shade inside here?
No, sir.
Now, because any value in between minus 3 and 5 over 2 is going to give us a negative value. So I can't do that. Um, let's say we take a value that is more than 5 over 2. Is that giving us a positive value?
Yes, sir.
Right. So we're going to shade there. Now, Nabil, in this question, you have to be careful again. If you notice, this was a rational inequality question. There was a denominator. So talk to me, Nabil. What value x cannot be? X cannot be what?
Mm. 3?
Yeah, x cannot be equal to minus 3. Understand?
Yeah.
Good. So when you're writing the solution, please keep that in mind, otherwise you're going to lose our mark. I don't want you to lose our mark. Right. So help me write my solution. I'm going to say that x is such that Tamanabil.
X is less than minus 3.
I see you didn't make the mistake. Can you say x is less than or equal to minus 3?
No.
Nah, because Serena, when x is minus 3, isn't that gonna make the function undefined? Serena, talk to me. When x is negative 3, what's that gonna do to the function?
It's gonna make it undefined.
Right, so you can't include that in your solution. You had to say x is less than minus 3, strictly speaking. Right? Nabil, and then union. By the way, guys, you could write union or you could write the word or, right? I like to be a little fancy, so I write union. Yeah, and Nabil, x would be what?
More than or equal to um 5 over 2.
And it's okay for us to use 5 over 2, right? Because when I put 5 over 2 into the denominator, right, it is completely correct. It doesn't give me 0, so I could use that. And let me blow all your minds. Come on a second. I believe that the Casio calculator should be able to do this entire question. Should be able to. Okay. Come on a second. Oh, it could do it, but you'd have to expand it out first and all kind of thing. Yeah. So that'll be more hassle than it's worth. Do you all know how to verify if your answer is correct by chance? Yes or no? Can somebody tell me how you would verify if your answer is correct? Nabil, you have any idea so how you could check if your answer is correct or not?
If it's not equal to 0,
If it's not more than 0, if you're wrong, right? And actually, Nabil, I would advise you to look at the original thing with which you started with. So, Nabil, at the start, we wanted to prove, okay, we wanted to get the values for x. That when you plug it in, will give you what? What did we want to get at the start? We wanted to get values of x that would give us what?
more than 1, more than equal to 1.
Right. So, let me verify that now. So, let me just say I pick 5 over 2, right? Because that's part of the solution. X is more than or equal to 5 over 2, so I could pick 5 over 2. So that's going to be 3 by 5 over 2 minus 2 all over 5 over 2 plus 3. And that is supposed to give us, I believe, 1. Supposed to. So, Nabil, what is 3 by 5 over 2? You know what? I can just plug this into my calculator and save time. Plug it into my calculator and save time. So that'll be 3 multiplied by 2.5. Why? Because 5 over 2 is 2.5, right? Minus 2 all over 2.5 plus 3. Bam! Nabil, look, watch that now. Watch that. Watch that. Watch that. Watch that. You see? What we got? What we got, Nabil? What we got?
1.
Yeah, that's crazy, right? After we do all of that madness. Yeah.
Mm-hmm.
All the cards are cool. Zachary, you thought you'd get one or not?
Yes, sir.
Okay, okay. Sometimes you just have to stand back and be like, wow, it actually worked. Yeah. So when x is 5 over 2, we do get 1, right? And Nabil, if I took a value for x that is more than 5 over 2, I'm supposed to get a value that is what? Talk to me, Nabil.
More than 1.
Yep, I'm supposed to get a value more than 1. So what's a value greater than 2.5?
4, 3.
The 3, we could use 3, why not? So when I press equal here, I'm supposed to get a value that is more than 1, right?
Yeah.
Let me see. Right, that is more than 1. Cool, cool. So we good, right?
Yeah.
And what was the other part? What was the other side of the solution? What was the other side? Talk to me. What was the other side? So we consider x is more than or equal to 5 over 2. What is the other side?
X is less than minus 3.
Give me a value that is less than minus 3 for now.
Minus 4.
Right, so I could say 3 multiplied by minus 4, right? Minus 2 all over minus 4. And again, when I press equal, I'm supposed to get a value that is,
More than 1.
watch that. Maths is very cool. I get 14. Right, we get 14. It was more than 1. So word. And this is how you check if you're correct, right? Whatever you do in maths, when you plug it into the original problem, you're supposed to satisfy the problem. So we wanted to figure out where x is supposed to be more than or equal to 1. So if you want to check over, just verify that your solution set is giving you values more than 1, more than or equal to 1. So great. Right, Nabil, in this question, what gave you probably the most trouble was probably the LCM, yeah? Probably the LCM, I feel. Or nah, was it not the LCM?
I think it was the LCM.
Well, let me show you an easier way to work with that, right? You was alright with moving across the one and thing, and
Yeah.
alright. Watch this, right? I could I could write 3x minus 2, right? So I'm gonna write 3x minus 2 all over x plus 3. And talk to me, right, Nabil? If I look at this, SCA maths now. If I had a half plus 3 over 2, what would that be?
Mm,
What would
That
that
would
be?
be 4/2.
That would be 4 over 2, right? Because anytime you have the same denominator, you could add or subtract the numerator, right?
Yeah.
Okay. So in this question, we had 3x minus 2 over x plus 3 minus 1, right? Yeah?
Yeah.
Okay, now watch this. What's another way I could write 1 using x plus 3 as the denominator?
X plus 3.
Yep. X plus 3 over x plus 3 is 1. Do they have the same denominators now?
Yeah.
Yeah, so now you can say 3x minus 2, and then you're minusing everything on top. So that'll be minus x minus 3. Since they have the same denominator, you could just write over x plus 3. And yeah, it should be really good from there. Shouldn't have a problem from there. So that's an
Mm-hmm.
alternative way you could think about it. Instead of, well, this is technically LCM, but in a different way to look at it. So you okay with this question?
Yeah.
Well, would. Zachary, yes or no?
Yes, sir.
Well, would. Hear what, right? Guys, I will let you take a screenshot of this. Take a screenshot, and I will give you all number 3 to try on your own. Yeah.
Say number 3 red.
Number 3, weird. It's the same concept to this. It's the exact same concept. I promise. Literally the exact same thing. Oh, the only difference is instead of 1 is 2, but you're repeating the same process, Nabil. So instead of moving across 1, you can move across minus 2. And then you would find the LCM. Again, the LCM would be x plus 3, right? Well, in that question, it would be x minus 3, right? And it would be minus 2 by x whatever that is. And yeah, it's the same procedure. So Nabil, it's the same procedure. Again, you have to find the LCM.
Okay, sir.
Yeah. So take a screenshot of this, make sure you have it. As soon as you do, let me know, right?
Yes, sir.
All right. We missing Caleb, boy. No Caleb day. Hmm. All right, so you'll have a screenshot, right?
Yes, sir.
Mm.
Great. Good luck. I'm giving you all 5 minutes. Okay, take 7 minutes. If you're not getting through at 5, just tell me. But I swear to God, it's the exact same procedure as the second question. The LCM might be a little more difficult, right? But it's the exact same procedure. Sheena, I believe you would have got through with question 3 as well. Or no? Okay, yeah, Sheena, you there? Can I hear you, Sheena? But Sheena, your answer would appear to be half correct. Half correct. You forget something. I think you
Okay,
know.
sir.
I think you know what you forget.
Mm-hmm.
In the last statement, right, in the last line, you can tell me what's wrong with that last line. Where you say the answer. This is a rational inequality question. What value of x would make the function undefined, Shina?
0.
No, not 0.
Oh crap, sorry.
Mm-mm. When the denominator is 0. What would make the denominator 0? Shina?
Yes, sir.
Yeah, what value for x would make the denominator 0?
Positive.
Right, positive.
Oh,
So fix the one mistake you make in our entire weekend. One mistake.
okay, sir. Thank you.
No problem. Serena, let me know if you're there.
Yes, sir.
Serena, you also handled it very skillfully. One thing though, remind me.
Yeah, I see.
Oh, you know already. Yeah.
Yes, sir.
Okay, good. Okay, talk to my guys. Zachary, were you able to correctly move across the two and find the LCM?
Yes, I think so.
Okay. Nabil, talk to me. Things bad or things okay?
Things good, things good.
Okay, good. Avinash, I hope I'll be honest with me. If I'll having trouble with anything, that's fine. I hate to help all you. We gotta be honest with me. Right? Avinash, what going on?
Think I good, sir?
You think you're good? Okay. Okay, so the time running out. Send me a picture where you have so far. Let me see what going on up to this point. So wherever you reach, take a picture and send it to me. All right, so Nabil, we have some work to do, but you got most of it right. So good job. Right, so Nabil, you there?
Yeah,
All right, so Nabil, we want to figure out when you come down to the part with the factorization, right? We want to figure out where everything is less than or equal to what?
0. I mean 2.
No, less than or equal to 0. All right? I'm talking about the line where you have 3x plus 4 by x minus 3 is less than or equal to 0. So we are trying to see where it's less than or equal to 0, yeah?
Yeah,
Okay. So I want you to look at your graph and I want you to shade the region where you're getting less than 0. If it's less than 0, it's positive or negative.
negative.
Right. So I want you to shade the region where you're seeing negative.
Okay,
Look at it and make sure what you're doing makes sense.
okay.
Zachary, what going on so far? Okay, I see it's on my picture.
Yes, sir.
Hey, Zachary, you look like you're chilling with that one. Good job. I would you do anything I would tell you to do again? Shade the correct region.
Uh, yes, sir. All right.
Yeah. All right, Avinash, I'm gonna check where your son there.
Yes, sir. Phone crashed to that one for some reason.
No shucks. And I don't want to download either. Don't want to download the picture you sent. Okay.
This one of our setup problems, yeah?
Okay, it has some work we had to do. Has some work we gotta do. Right? That's fine. We can do the work. So Avinash, let me start off, right?
Yes,
First
sir.
things first, you're accustomed dealing with questions that are less than or equal to or more than or equal to 0. That being said, we are going to make an effort to move across the two.
Ah,
That's
yeah,
what you do.
yeah. I
No,
think
that's
I,
what you do that. I'll tell you the point in which things went wrong.
so I
So,
noticed the sign mistake already. I'm not watching it back.
oh yeah, yeah, change it to more than or equal to
Yeah,
as
yeah, I know. It's,
right. So 5x minus 2 all over x minus 3. Gonna move across 2 is gonna turn to minus 2. Less than or equal to what?
0.
Right. Now you have to be very careful here, right? Right, Avinash, extremely careful. So how you want to do this? Using the long LCM method like this or the shortcut like this? One or two?
Uh, try to.
You want to do it using option two?
Yeah.
Okay. Right. So, Avinash, look carefully, right? Look very carefully. If I wanted to combine these two, then I would need to have the same denominator. What denominator are you seeing in this question?
X minus 3.
X minus 3. Yeah. So I would need to write this as something over x minus 3. I would need to do that. So Avinash, imagine you had 1, right? How would you write 1 as some number over x minus 3? What do I have to put on top?
Um,
Okay. If you wanted to write 1 as something over 5, what would you put on top?
so that's like 1.
Nah, 1 over 5 is 0.2. That's not 1.
Okay. Um, 2.
No, 2 over 5 is 0.4. I feel like you're
Um,
guessing. Okay.
yeah, no.
Let me think about this logically, right? What
Yes, sir.
number could 5 go into one time?
5.
Right. 5 could go into 5
Ah,
one time. So what
yeah,
would I
yeah.
need to put on top to give me back 1?
Um, X minus 3.
Right. X minus 3. So it's a similar concept you're going to apply here. Watch this carefully. So if I wanted to get 1 right, I would have written x minus 3 all over x minus 3. Yeah?
Yes, sir.
But I want to get what?
2.
So if I wanted to turn 1 to 2, I would have to multiply 1 by what?
2.
Right. So if this is 1, I would have to multiply that by?
2.
Right. So I'm going to write 2. And watch, this makes sense because Avinash, if I cancel off the x minus 3 and the x minus 3, what would it leave me with?
0. Or just 2.
Just 2. So it would give me back the original thing. So I didn't change anything. Right? Let me run that back one more time so they understand. I'm going to write back the 2, right? Okay. Talk to me, Zachary. I mean, what's saying Zachary? Talk to me, right, Avinash?
Yes, sir.
I want a denominator of x minus 3. What should I put on top here?
This is about X minus 3.
Right. Because x minus 3 over x minus 3 is actually what?
2. So 1. 1.
1, right? And 2 by 1 is
Wait, 1 is 2.
2, right? So do you understand that okay, we didn't change anything, right? This still means this. I hope you're not confused, right? Because watch, we just wrote x minus 3 over x minus 3. If you were to cancel it off, you'll get back where you had above. The
Yes,
only
sir.
reason that we did this is so that we could have a what? Why did I do that?
So you have a, some,
Talk to me. Tell me whatever comes to mind. Don't be
like,
shy.
let's say the denominator, but not that,
A common denominator?
yeah.
Yeah, a common denominator.
That actually, that's slow today because I wake until like 3 this morning right now, something with bio.
That is okay. The point is you're here and you're trying, that's good. Right? So Avinash, you see this negative 2 here?
Yes, sir.
Be extremely careful with this. You're gonna take the negative 2 and you're gonna multiply it by every single thing inside of the brackets. So what is negative 2 by x?
Negative 2x.
What is negative 2 by minus 3?
Uh, 6
Plus 6.
plus
Positive
6.
6. And since both of them had a common denominator, what is the denominator?
X minus 3.
X minus 3. Great. We need to simplify the numerator now. What x terms are you seeing in common?
5x and 2x. So
What is 5x minus 2x?
3x.
Okay, what numbers are you seeing in common?
2 and 6.
What is negative 2 plus 6?
4
Yeah, plus 4.
plus 4. Yeah.
So yeah, now with 3x plus 4 all over x minus 3 is less than or equal to 0. Is that something you're accustomed seeing, this form?
Yes, sir.
Right, and in all the previous questions we had do so far, it was more than or equal to 0.
Yes, sir.
Yeah, we are accustomed seeing it like that. So shouldn't be a problem from here. What to do next?
Then on then times it by the x minus 3.
Right? And we're going to
Right?
times it by x minus 3 or x minus 3 squared.
X minus 3 squared.
Yeah, x minus 3 squared. Right? So x minus 3 squared. You okay with that?
Yes, sir. Then it cancels off.
Right. So x minus 3 squared would mean x minus 3 by x minus 3 on the left-hand side. So one of the x minus 3's would cancel off with one on top. So that would leave you with what here?
Um, leave it with 3x plus 4 times x minus 3.
Right? And on the other side, what is 0 by anything?
0.
Right. So from here now, I'm going to put this equal to 0, and I'm going to find your roots. Right. So now I'm going to say, I'm going to write 3x plus 4 is equal to what?
0.
What next?
Then you'll move the 4 across. No. Yeah.
Yeah.
Well, yeah. Yeah. You come minus 4.
Mm-hmm.
Then you divide by 3.
Right.
Okay.
What next?
Then you say for the x minus 3.
Right? But I equal to?
And that's positive 3.
But I equal to 0, and x would be equal to positive 3. Right. Now I need to draw my diagram. Sketch my graph. So everybody, wait, give me a second. Let me just draw this. Y, X. Everybody in class, talk to me. Which line am I going to look at to sketch my graph? Which line am I going to use to sketch my graph? Does anybody know? Avinash, do you know?
First one, sir?
No, not
I
the
mean,
first one.
no. Oh, no, I thought you meant, sorry, sir. I thought you meant which one, which thing it will be.
Nah,
So
you don't.
line 7.
Yeah, you're gonna use line 7. Last line. Avinash, you're gonna use the last line, right?
Sorry, sir. I thought you meant by the minimum maximum thing.
You're gonna use line 7 for that as well. So
Yeah.
Avinash, if you expand this, what would the x squared term be?
X by X by X.
It will be 3x by x.
Yeah.
What is 3x by x?
4x.
Nah, you're multiplying.
Oh, it's
Multiplying.
multiplying.
Mm-hmm.
Um,
So what is x by
this way.
x?
X by X. X squared.
Right? So that'll be 3x squared. So the number
Yeah.
in front of x squared is positive or negative?
Positive.
Right. So my graph is going to be a minimum or a maximum?
Minimum. Nope.
Right.
Maximum.
No, minimum.
Minimum. Yeah, minimum.
If it is positive, imagine that it's smiling, right?
Yeah, minimum.
Minimum, right? It's smiling with three teeth.
So,
Yeah,
so
smiling with three teeth. Yeah,
Yes, sir.
yeah, Zachary.
I have to leave now.
Okay, no problem. Thank you for coming to class today. It seemed like you was able to understand what we do, which is good.
Yes,
Right?
sir.
I will see you in the next. I'll see you tomorrow. Tomorrow morning.
Yes, sir. Yes, sir. Tomorrow for sure.
Right. Well, you take care. All right. So yeah, Avinash. My roots are going to be what? What are my roots going to be?
Minus 4/3 and 3.
Right? Minus 4/3 we could put it over here. And 3 we could put over here. And it's going to be a minimum. Great. Great. Now, Avinash, we are trying again, we're using line 7, right? The last line. Well, I should say the second to last line. Avinash, if you look at this, we want to figure out where it is what?
Um, Less than or equal to 0.
If it's less than or equal to 0, maximum or minimum? What I'm saying, what I'm saying.
Uh,
If it's less than or equal to 0, right? Positive or negative?
Negative.
Right, because it's less than 0, right? Okay. If I take a value for x that is less than minus 4/3,
Yeah,
am I
positive value.
getting am I getting positive or negative?
Positive.
And that is more than 0, but I wanted less than 0, yeah?
Yes, sir.
So can I shade over here?
No, sir.
Nah, can't do that. What about if I go between minus 4/3 and 3?
You got negative.
Do we want a negative?
Yes, sir.
Right, so I'm going to shade in the middle. So Nabil, I saw that you eventually figured it out. Good job. So Nabil, can you leave the answer that you had?
Um,
So let me check the last thing you said, man. Right, so Nabil, if your answer is in between two values, can you write it? Can you write it like the previous answers? And I had to write it differently.
differently.
Here, anytime your answer is in between two values, you have to write it like this. So my answer is going to be x is such that, right? You're going to put the smaller value first. Now let's just check something out, right? Nabil, if we look, Nabil and Avinash, if we look at the original thing, what was the denominator?
X minus
X.
3.
So what can't x be equal to?
My plus 3.
Yeah, guys, x can't be equal to 3, right? Because when x is 3, it makes the denominator what?
0.
Right? And you
0.
can't divide by 0. That's undefined. So when we write in this, right? We could say minus 4/3 is less than or equal to x, but we cannot say less than or equal to 3. You need to write less than 3. That's the answer. So, guys, anytime your answer is in between two values, generally you follow this format. A is less than x is less than b, right? Where a is the smaller value and b is the bigger value. So, yeah. So, Nabil, here I was saying, right? Once your answers is in between two values, you use this notation. So, our answer was from minus 4/3 to 3. Which one is smaller, minus 4/3 or 3?
Minus 4/3.
Right? So I'll start off with that. Um, minus 4/3, I could plug that into the denominator, right? That wouldn't give me 0, so I could include it. Look at the sign. The sign was less than or equal to. So if possible, I should put equal to. Right? So I put equal to for minus 4/3, but I can't put it for 3. Why, Avinash? Why can't I put it equal to 3 as well?
because it'll end up being 0.
Right, the denominator will end up being 0. Right? I should probably make a little note about this because when all you're using these notes to study, hopefully, maybe you might forget. So let me just put a little note here. Okay, so that's it for quadratic inequalities. Are we okay with the subject now? Are we okay with the topic? Talk to me.
Yes, sir.
What about the rest of you guys? Are you all okay with the topic now?
Yes, sir.
Yes.
So Nabil, you feeling you're 100% confident with this or not?
Yeah.
Yeah, boy, you said I kind of unsure, you know. I don't know how to feel about that. Say that.
No, I understand everything.
Okay, good, good, good. Right, Serena, you okay?
Yes, sir.
Yeah, sure.
Yes, sir, I'm sure.
Okay. Avinash, I notice I still having some trouble. So maybe I could give you extra questions for homework. But I think you could definitely figure it out. You just need to practice more.
Yes, sir. Now that I realize, like, if you have more, you have to square it also. Yeah, I think I could figure it out now.
I think so. Right? So when x is equal to 3, it makes the function undefined. Everybody okay with that? Alright, and let me just add that in for the others too, right? Shayna, you have anything that you're not sure about with regard to this topic? Shayna, can I hear in Shayna? But I'm gonna assume Shayna is good. Shayna is really smart. When x is equal to 3. Okay, great. So are you sure that are you ready to move on to some product roots now? Let me know, guys. We ready to move on?
Yes, sir.
All right. Nabil, Avinash, talk to me.
Yes, sir.
Okay. Serena.
Yes, sir.
Okay, good.
Hi.
Hello. Give me a second, eh? Right, so let's continue. So we are going to look at sum and product of roots. Right, sum and product of roots. You're not going to learn this in school, but the proper name for this is Vieta's theorem or Vieta's formulas. So if you want to flex on the teacher, because I sure most likely a teacher wouldn't know about this, you could ask them, right? When I was in secondary school and I had asked my teacher about this, he didn't know what it was. But it's the same thing he was teaching. So Vieta's formulas. That's the proper name for it. And this is something you have been acquainted with, but you just didn't know about. So Serena, you know how we just factorize quadratics?
Yes, sir.
Let me give you a little example, right? But it's the same thing. It's the exact same thing we're gonna look at here. Right. So let me get a quadratic quickly. Okay, I just hear something groundbreaking. But anyways, example. Wait, I shouldn't put example. Let me just look at the concept. Right? The concept. I promise this is not anything you didn't see before. The concept. Wait, let me get like a sticker. Wait, no, I resizing. Serena, when you see this, you're gonna feel exactly like this. I hope at least. Nabil, what are your thoughts on maths? You feel like you like it, or you feel like you don't like it? You can be honest with me.
I like it because I'm a teacher.
Okay, that's good. Right? So we're gonna look at the concept. So Serena, I'm gonna give you a quadratic to factorize, right? So let me just think of one real quick. So maybe x squared, x plus 2. Right. Let's factorize this. So x squared plus 5x plus 6. So Serena, here what? Let me factorize this, right? And let's actually solve for the roots one time. Let me do that, shall we?
Yes, sir.
So Serena, how would I factorize this?
First, we look at the C value and see what two numbers would give you the product of 6, but add to give you 5.
Right. So look at the C term. What two numbers have a product of 6? Right? And then the other question they're gonna ask is, what two numbers also have a sum of what?
5.
Right. So I want you to keep this pattern in mind, right? Keep this pattern in mind. Please. So, Nabil, if we're looking at the C term, right? The C term is 6. Let's answer the first question. This is the first question. And this is the second question. Nabil, what two numbers has a product of 6?
3 and 2.
Right. Right. They have a product that will give you 6. Onto the other part, right? What two numbers also have a sum of 5? Well, if you add 2 and 3, what do you get?
5.
Great. We know this. This is nothing foreign. So if this is the case, we can now factorize it. So what are my factors going to be? What are my linear factors going to be, Serena?
Positive 2 and positive 3.
Right, so I'm going to write x plus 2 and x plus 3. And that is going to be equal to what?
To 0.
0. So up to this point, you're with me, right?
Yes, sir.
Okay. Nabil, you with me so far or now?
Yes, sir.
Okay. Shayna, you okay with me up to this point?
Yes, sir.
All right, so guys, again, this topic is called the sum and product of roots. I'll probably already see what we're talking about. What two numbers have a product of 6? What two numbers have a sum of 5? All right. So, Serena, let's solve it, right? So you put x plus 2 is equal to 0, and they would say x is equal to what?
Negative 2.
Right? You would say that x plus 3 is equal to?
0. So x is equal to negative 3.
Yep. Okay. Let me show you something, right? Aren't these your roots?
Yes, sir.
Right. To factorize, let's look again what we did. We looked at the last term. To get the last term, didn't we look for two numbers that have a product of 6?
Yes, sir.
And we also look for two numbers that would have a sum of 5. Great.
Yeah.
So if I wanted to write my original quadratic in terms of its roots, this is what I could do. So it would be x squared, right? Look how I'm doing carefully, right? So it's going to be x squared minus the sum of the roots right? Plus the product of roots. And that is going to be equal to 0. You're probably wondering, well, where am I going with this? Serena, you fully
Yes, sir.
understand this concept, right? Like, yeah, you fully understand this. How we get it 2 and the 3.
Yes,
Now,
sir.
when you find your roots, aren't you changing the sign? So this positive 2 turns to negative 2 and this positive 3 turns to negative 3.
Yes, sir.
So if I wanted to get back 5 and I added negative 2 and negative 3, wouldn't that give me negative 5?
Yes, sir.
So for me to get back positive 5, wouldn't I have to say minus the sum of the roots?
Yes, sir.
Right, because to get 5, we said it was the sum between 2 and 3. But when you find your roots, you actually change the sign. So to get back positive 5, you need to put a negative sign on the outside. Right? And well, it don't matter over here, right? Because where's negative 2 by negative 3?
Positive 6.
Right. So let's test this theory that we came up with. So x squared, the sum of the roots. Nabil, how would these sum of the roots be?
Minus 2 plus minus 3.
Right, minus 2 plus minus 3. X, right, plus the product of the roots. What would the product of the roots be?
Minus 2 multiplied by minus 3.
And if we do everything correct, Nabil, I'm supposed to get back the original quadratic. I should. I should be able to get it back.
Yeah.
Right? So Avinash, what is minus 2 plus minus 3?
Positive 5.
Nah,
No, wait.
it wouldn't be
No,
positive 5.
minus 5.
Minus 5, right? And what is negative 2 by negative 3, Avinash?
Positive 6.
Right? Positive 6. And that'll be equal to
0.
0, right? Right? What is a negative by a negative?
Positive.
Avinash, doesn't this look very familiar to what we started off with?
Yes, sir.
Is the exact same thing. Serena, you see what I'm talking about?
Yes, sir.
So, Serena, if you want to reconstruct a quadratic, you can use this equation, granted you know what the roots are. So if you know what the roots of a quadratic are, then to reconstruct the quadratic, it's going to be x squared minus the sum of the roots by x plus the product of the roots, and that'll be equal to 0. Great. I hope everybody understands that. Does everybody understand that or not?
Yes, sir.
Right, so guys, you all could copy this down quickly. This is the main thing that I need to remember. You need to remember this. Please lock this into your memory. That's how you reconstruct a quadratic. If you have the sum of the roots and the product of the roots. It is also what you'll be using to modify quadratics. Please remember that. So copy that down, and as soon as you're done, I'm going to show you the formula for the sum of the roots and the formula for the product of the roots. There's a formula, and it's Vieta's formulas. Did any of you guys do this in school as yet? Or not?
No, sir.
No? Alright. Right, so as soon as you have this copy down, let me know, right? And this topic is, oh, I suppose yeah, the topic is sum and product of roots. Um, Formerly known as Vieta's formulas, and I just showed you all the concept. Three and I have everything copied down.
Yes, sir.
Okay, what about the rest of you guys? All right, Nabil, Sheena, talk to me, guys.
Yes, sir.
Well, would. So please remember this, right? So without looking, tell me, how would I reconstruct a quadratic if I know the roots? Talk to me. What's the formula that I need to know? If you have the roots, how would you reconstruct the quadratic?
X squared minus sum of roots by x plus sum of plus product of roots equals 0.
Okay, great. Right. So Sheena, in this example, we had numbers for the roots, right? We had -2 and -3. Yeah?
Yes, sir.
Right. In this topic, though, right? In this topic, we are going to use alpha, alpha, and beta to represent the roots. So Nabil, don't get scared, right? Please don't get scared, right? Um, in other words, I could have called this alpha and I could have called this beta. So alpha and beta is just the roots, right? It's gonna use alpha and beta to represent the roots. Alpha is one of the roots and beta is one of the other roots. Understand?
Yes, sir.
Okay, good. So in this topic, we are going to use alpha and beta to represent the roots. So I would write, so these are the formulas you need to be familiar with. So the sum of roots, right? Again, the roots are alpha and beta. So the sum of the roots will be written as alpha plus beta. And the formula for that is minus b all over a. Right? And so I probably could figure out why I'd have a negative because remember, when you find the roots and the sign is changed,
Yes, sir.
so that's why I put a negative sign over there, right? And the product of roots. That's alpha by beta, right? And that's C all over A. Great. So guys, copy that down, right? And we are going to verify this with the previous example. So Serena, just remind me, what were your roots? What were your roots for this?
-2 or -3.
Right. Yeah, so we found it to be x is equal to -2 and x is equal to -3. Yeah? Yes or no?
Yes, sir.
Right. So Serena, if I wanted to find the sum of those roots, so we just tested the formulas, right? And please, guys, you have to remember this. Please remember these formulas. Please, please, I beg. Right? These formulas you have to remember. All right? Those ones over there. And we're gonna test it now. Right, so let's test this, Serena. So if I wanted to add my roots, right? The sum of roots, as I know it, that would be equal to -2 plus -3, and that would give me what?
-5.
Right, and that's using what we came up with, right? But what would happen if we use the formula? Let us use the formula. So according to the formula here, right? The sum of the roots, alpha plus beta, that would be minus b over a. Guys, if you're looking at this, what would a, b, and c be? Guys, if we're looking at this, what would a, b, and c be? Nabil, what would a, b, and c be for this?
A will be 1, B will be 5, and C will be 6.
Right, so if I use any formula, that tells me the sum is minus b over a. That's going to be minus 5 all over 1. What's minus 5 over 1? Somebody, where's minus 5 over 1?
-5.
Right. So Serena, by using the formula, did I get the same answer as if you did it the long way?
Yes, sir.
Yeah. So the formula is correct. That's great. That's good news. Right? I'm going to a new page. Yay! The formula works. Right? The formula does work. Let's test the other formula out now. What's the other formula, guys? What's the other formula? Guys,
Alpha by beta
alpha by beta, which is the product of the roots, which is equal to c over here, right? So
is
the product, let's test it first with the roots we came up with. So the product of the roots, that would be equal to the minus 2 by the minus 3, yeah?
is
And what do you get if you do that?
+6.
Good. Now, let us use the formula and see if we get that back. So it's c over a, right? What is c?
C6
And a is?
on
What is 6 over 1?
6
Does the formula work?
is
Yes, it does. Great. So what I taught you there was the essentials, right? So you need to know these formulas over here. You need to know that alpha plus beta is b minus p over a. And you need to know that the product of the roots, alpha beta, is c over a. So copy that down, copy down. We had to copy down. And I will give you all some homework. And in the next class, we will finish this topic.
excuse you.
Yes, Serena?
For the part like on the product of roots, when you put letters, use the formula, you didn't fix the alpha by beta,
Oh,
it's still alpha plus beta.
sorry about that. Good point. Supposed to be alpha beta because it's the product. Good. Alright, so have this copy down. Nabil, is there anything here that you don't understand or you don't believe?
No.
No? Alright. Before we end the class, I'll make sure that you'll remember the formulas. Because you need to know these formulas. You need to. These formulas are a must. Hey guys, as soon as I have all of this copy down, let me know. Okay, do you guys have this copy down?
Yes, sir.
All right. Sheena, Serena, do you all have it copied down?
Yes, sir.
I bet.
Yes,
So
sir.
let's just review this, right? So first things first, guys. Alpha and beta, what do they represent? What does alpha and beta represent?
Roots.
Right. Alpha and beta just represent the roots, right? If I want to find the sum of the roots, alpha plus beta, how do I do that? What's the formula for that?
Minus B over A.
Right. If I want to find the product of the roots,
C over A.
right, that would be C over A. And if I want to reconstruct my quadratic, how would I do that? Granted, I know what the sum and the product is. How would I do that?
X squared minus sum of roots by x plus product of roots equals 0.
Right? So in this case, it would be the sum of the roots, which is alpha plus beta x, plus the product of the roots, which is alpha beta, and that'll be equal to 0. Great. Yeah, I mean, if you guys understand that.
Yes, sir.
So this is what we have to know, right? You have to know this. So the sum of the roots is represented by alpha plus beta. That's the sum of the roots. And the product of the roots is represented by alpha by beta, which is C over A. So, yeah. That's it. Let me see if I can give all that easy question. I don't know if you guys would be able to figure this out, but give it a try. My hint is, guys, here's my advice, right? In any question that you get, find the sum and find the product. So find alpha plus beta and find alpha beta. That is my advice, right? My advice with these questions is typically to find LCM too. So this is my advice, right? Find alpha plus beta and alpha beta first. Find LCM. That's my advice. So take a screenshot of this and put it in the chat for me. Somebody take a screenshot of this and put it in the chat for me fast. And that'll be it for class. That'll be it for class today. All right. So yeah, that's it for class. And do any of you guys have any questions? Talk to me, guys. Do any of you guys have any questions?
No, sir.
All right.
Okay.
Well, I hope you guys have a blessed night. Take care, guys. Later.
Same to you, sir. Bye.
Bye bye.
See.